All right, it's all you. We see it, Robert. Go ahead.
Say PromoStandards Hackathon, because that's what it's supposed to say there. All right.
Got it.
So this is our presentation for the PromoStandards Hackathon today. We're on the Happy Cachers team. This is basically what I'm going to talk about: our project concept, our team, the goals we had for this project, what technologies we used, and the architecture we used to develop it. I'm going to show you a dashboard we developed in a live demo. So hopefully I'll get through that quickly. I won't speak quite as quickly as I spoke during my little spiel. This one, my pitch. So the concept is a maintenance-free, supplier-hosted product pricing and configuration caching proxy. So what is that? A caching proxy is a server that goes in between a client and another server, and it responds to requests on the server's behalf. Caching means it keeps the data itself, a copy of the data. Maintenance-free means supplier doesn't have to do anything after they set it up. And it's supplier hosted, meaning the supplier is the one who's putting it on a server for their own benefit. On our team are me, Robert from commonsku. I'm a software developer. I did the software development. And Mike Pfeiffer, who's from the distributor, American Solutions for Business. And he helped me decide what we should put on things and developed our slides and our t-shirts and all our other stuff like that. Okay, these are our goals. And we wanted this proxy server to be fast. Because often PPC responses especially are slow, especially when you're getting customer data. Wanted to be no maintenance, so the supplier didn't have to worry about it. We wanted to have rate limiting on an IP and account level so that there was, it didn't cause, you wouldn't have to worry about that sort of thing. You wouldn't get DDoS. We wanted it to flag PPC data issues because some suppliers whose names I won't name sometimes give data that doesn't look pretty. We need a dashboard so you can see what it's actually doing. A stretch goal is to provide a RESTful API, and you need to be able to invalidate the cache in case you've updated your backend data, although it should invalidate itself and fetch new data periodically in any case. Technologies we used. Tried out some new technologies that I've never used before, so I was coming at this from a clean slate. Ones that I have used, obviously all the PromoStandards ones. Docker, never used before. We used that to help with the no maintenance part of it. Redis for our data store, TypeScript for the language. Dino, which is node replacement as to run the TypeScript. Dino Fresh, which is a brand new web application framework. Preact, which is a mini version of React. It doesn't send 6 megabytes to your browser every time you load a page. And Recharts for building our dashboard. So here's kind of what the architecture is like. The client sends a request, gets intercepted by the proxy. Proxy says, oh, do I have that a copy of it? I'll check in Redis, see if I've got it. If I do, I send it back to the client. If I don't, I'll go to the supplier, I'll get it, I'll send it back to the client, and I'll cache it in Redis. Meanwhile, in the background, we have a bunch of workers on the right here who are continuously polling the supplier to check the product data service to see which products it needs to cache, and also querying for each of those products all the PPC endpoints, caching them in Redis. We also got some stats workers who are building stats based on the products and the requests that get sent in because we log every request in each direction. If you go to this link here, you can get some information on our architecture where it's spelled out in great detail. Okay. Here's just a image of our dashboard. I'm just going to go take you to a live version. I don't know if you can see this.
We got it. We see it.
All right, here's our PPC caching dashboard. Unfortunately, this is not live data. My stats workers are still working in the background, trying to compile all that. But there was only the one of me writing them. But the basic idea is you can see how fast the proxy is going. These are the durations at the top of the various different methods on the service, and how long it's taking for the proxy to respond versus how long it would have taken, or how long it takes the proxy to get the data originally from the supplier's server. This is how many requests that we're making that are coming into the proxy versus are going out to the supplier. This is where in the world all these requests are coming from. This is the time of day of the week that you're getting requests. These are the most popular products and why they're popular, what you're getting requests, how many requests you're getting, and at what method. These are your most active users and how many requests they're making to each method. And here are some of the data issues that we've discovered an unrecognized state on a get fob points request. You can ignore them, in which case we won't bug you about that one again. You can revalidate them, in which case we'll invalidate the cache and go fetch this data again. And if you get them all done, you are a happy camper. Now let me see, did I have any more? Does anybody have any questions?
Yeah, I have a question. Can you go back to your dashboard? So and we'll let other people chime in here with questions. Why are you smoking certain services with, I mean, the gap between in your graphs between milliseconds? I mean, you're not getting a lot on get decoration locations, but you're really crushing it on get configuration and pricing. You know, what explains the higher performance in certain methods over the others?
In this case, it's fake data. That's what explains it here. In the case of ones that I actually looked at, but didn't graph because I only had like a few data points, there's not too much difference in the first four categories here. The differences really come in the second, the fifth and sixth categories here, in that I have this data stored in a denormalized format, and I don't have to go back to the supplier to get it. It's already in a fully hydrated format, so I can just send it to the client.
So who's hosting this? The supplier is hosting the proxy?
A supplier would host the proxy. Anybody could host the proxy theoretically, but if the supplier hosts the proxy, he can tell all his clients or her clients to use the proxy. CommonSQ could host the proxy for you if it wanted to.
All right, Vera's got a question here.
Yeah, this looks really good. I'm very impressed with the UI on this. So great job on that. How long did it take you to string all of this together?
We started on, what was it, Monday last week?
This week, yeah.
Or this week? No, we started last week, wasn't it?
Yeah,
Today's
right.
Monday.
Yeah, kick off was Monday.
Whenever the teams were decided, that's when we did it.
And did you build anything for how and when the data is refreshed?
Right now, we go get the product sellable every day. And if the product sellable change, then we fetch any of the new sellable products into the database. If it doesn't have something in its database already, it'll go back to the supplier to get it. and store it, and then it starts some background processes to go fetch the additional methods so that it can have a full cache. It also, as different users with different credentials come in, it stores their credentials, and then it uses the same response for all the ones that should be the same across users. So all of them except the get configuration and pricing by customer. That's the only one that it does, that it requires that different data for different accounts. So we hash the price lists, and we get a pointer to a price list that matches your credentials because we fetched it, so that we can save on some space with storing the data. What else did I want to see? Some actual timings I can probably show you if my.
Robert, while you're getting that, you mentioned you use a new graphing chart library. Thoughts on this one? Good, ugly, good choice?
It was simple.
Okay.
So this is a customer data came back in 430 milliseconds. I'll just say when I originally fetched this from the supplier, it took 35 seconds. So it was a little bit of an improvement. The other ones were not as remarkable, but it's really the customer data, and that's the hardest one to cache for service providers, especially because there's like M distributors, there's N suppliers, there's P products, so that's M times N times P. That's a huge amount of data. But because most of them probably share a similar price list for parts, and we can store a hash of that and just have one copy of it, so you know which one you're using. What was I going to look for? Timing.
Excellent.
So that was 297 milliseconds. Sure.
So that's great, Robert. I think you're trying to solve, and looks like you have solved for one of the performance issues that I think certain suppliers are returning very quick calls, and it looks like you're trying to solve for the ones who aren't and making up for the difference. So yeah. Great job. Amy, anything else here before we kind of wrap this up?
No.
Okay.
We're good.
It does do XML. These were just our we also provided REST endpoints. So
awesome. Robert, throw that in the chat, and then so that way we can check it out, because we're going to provide all the chat links to everybody after we wrap this up. So it's a lot. That's good. I like it. Good job.